Hello everybody, welcome back to the training of the M172. In this part, we're going to focus in the Modbus implementation, the PLC as a master, and this temperature and humidity sensor as a slave. So, in the previous part of the module, we have explained the offer of this temperature and humidity sensor. Now we're going to program in the PLC how we can communicate with it. In order to understand how the Modbus master works in the PLC, what we're going to do is to start using some function blocks to communicate, and then using the I/O scanner, and finally use the easy way to implement the communication with this device. So if we go into the presentation, let me just put it in the other way. What we're going to do is to connect the slave, which is the humidity and temperature sensor over Modbus, to the PLC, the small one that we have already programmed. We're going to use the serial line number 2, okay, which is the one that behave as a master and also a slave, but we're going to use it as a master. We're going to connect into these cables on the slave, okay, the ground and the ones for the serial ones, okay? And then we're gonna energize the humidity and temperature sensor in these ports 1 and 2. In the photo, you can see here these two connectors are for the power supply. You can see here P plus and G and D. Then the other three are regarding the communication. In the PLC side, you can see here how is the connection, okay? The white one is go to the second one pin. The third one is the GND, goes here, and the first one goes to the second port, which is the A+. Okay, so what we're gonna do, okay, in this device, okay, in the humidity and temperature sensor, we have these registers to get access. Some of them are only read-only, and other ones are only for read and write. We can see here that we have the communication, the Modbus, the parity and the stop bit, okay, to be written, and also we can read them. And we can also modify the address of this device. What we're gonna do in this example is to read these parameters, okay? The temperature and the humidity, not this one, the temperature and humidity. As you can see here that we cannot read those variables, we can only read only, okay? If we need to make some adjustment in the how the temperature and temperature sensor read information, we have some offsets here. So what we're gonna do now, okay, is to indicate the initial configuration of the humidity and temperature sensor. So when we open the case of this device, we can see here that we have some switches. These switches belong to this table, okay? In this example, I'm going to use this, the switch 1 and 2 in on. So I have by default this address 243, the parity bit even and stop bit in 1, and the baud rate selection in this value. So just to double check, if we go back, this is the possibilities for the stop bit, okay? 0 belongs to 1 bit, 1 belongs to 2 bit, the parity we have none, even, and odd, okay? And the baud rate, this is the baud rate available for this device. So if we continue forward, okay, what we need to do is to configure in our serial line 2 the device that we're going to use, okay? But first we need to configure the port in the PLC side in order to connect with this one with the same information that we have. So as you remember the Modbus communication, in order to connect with one as a slave, we need to have only one master and at least one slave, okay, which is the case. We have one master and one slave, and we need to match this configuration, the parity bit, the stop bit, and baud rate. That's why in the configuration, in the E-Construction Machine Expert HVAC, in the configuration tab, we need to match that. We have the baud rate, default, the serial parity, okay, in even, as you can see here. We have the stop bit in 1 and the data bit 8, okay. This one is for default in this one. So we need to match this information that we have in on to this one in the configuration in the PLC side. So now what we're going to do is to make a program in order to read some variables. That we're going to read is these two: temperature value read by the sensor and humidity. So now we need to open the application and make some code in order to read those variables. So now we're going to open our application, go to the configuration, select the port of master slave to use as a Modbus master for field. So we are the master in this port of the PLC, and match the configuration of the slave of the humidity and temperature sensor. Okay, so in this case will be the master. We need to match the baud rate. We need to match also the parity, the data bits, and also the stop. So quick look here, 96 even 81. Yeah, if we go to the presentation again, even 1. Okay, so everything seems to match. So we can compile this, and we can also set that here in the BIOS parameter. So we can predefine this, okay, with this information. 3 for Modbus, RTU. You can see the other options. 8, 1, even, and this is the velocity. So the configuration is done. The hardware configuration is done. So we should go now to the programming. So in the first part, we're gonna use the function blocks to get access to slave information in the register. So in this case, in this particular case, I'm gonna use humidity and temperature sensor, but we can use with whatever we want in Modbus. So the functions are in here in operators and blocks, and then we need to get access to the target blocks. Here you can see these functions. Okay, they are related to the Modbus function to get access to a device and read or write some registers. Let me go back to the presentation so we can explain this a little bit further. Okay, this is what I'm going to do now, but first I'm going to show you this. You can see here all the function blocks. In order to see what are the main purpose of this, you can see here. For example, the first one is the function code in Modbus, the function code number 1, which is related to read coils. In this particular case, we're going to be focused in this one, function number 3. Okay, this is the function that we have in the tool, in the E-Construction Machine Expert HVAC. The function code in Modbus is number 3, and then the purpose of this is to read holding registers, percentage MW. So if we go a little bit further, we're going to use this function block, the number 3, to get access to the information of the sensor. Okay, so let's go back to the program. Let's add a new POU. Okay, right click, add new program. I'm going to use the function block FPD. So let's put a name prg_com Modbus. Okay, And here's something important. This function block must be called in a background task. Okay, if not, if we use the time, we're going to receive an error. So, okay, you can see here in the task that now is called here in the background. So, these are the function blocks. If we are not able to see these operator and blocks, we just need to go to View, Toolbar, Tool Windows, and we have operators and blocks. Then just select this one. Let's go to the properties. Let's see what it says. Okay, you can see here the description for this function block. And if we receive this error, okay, 17, it seems that we have executing this function block in a time, and it should be the background. So let's select this function block, drag and drop into our program. So now what we're going to do, if we go back to the presentation just quick, what is the idea? I'm going to create these variables, okay? They're going to be related to the function block, okay? The address, the base, I'm now going to make a little bit of explanation on this. The address, okay, is the address of the slave, not of the master. So the slave in this particular case, let me just double check. I think it's 243, but yeah, it's 243. So the address in this particular case, as you can see here, I'm going to create this and assign single int as 243, which would be the address. And then here in the base, if we go back to the function block, here the base, okay, should be the first register that we want to read from the slave. Okay, so if we go back to the presentation, it has here the number 7, which is this one, the address number 7, the percentage MW7. If we go back again, we have a number, and O, which should be the amount of contiguous register that we want to read in this case. So in this particular case should be 2, okay, which should be one for the temperature and the other one for the humidity. And then we need to add this, which is an array where we can store the information that we want to read. And then we have the status and the timeout. So if you give me a moment, I'm going to create these variables. Okay, so we have, let's start again. With this button, we create a variable. I'm going to create an auxiliary, which will be petition read sensor. Okay, with this one, we're going to read this sensor and we're going to execute this function block. So how you can see here, if we drag and drop, there is no way to execute this when I execute this, when I put this variable in true. So what we need to do is to right click, enable output pin. So we will just drag here. Now when this variable goes to 1, it will be executing this function block to read information from the device. In this particular case, the humidity and temperature sensor. So let's create another variable. USE CFG address USInt initial value 243, which is the address. Now UE CFG and base. I use this CFG as indication that is configuration, and the initial value is 7. Let's go again. UE unsigned integer CFG underscore amount int. I'm going to read 2 contiguous registers, And then I'm going to use for indication object. This will be linked to the amount of information that I want to read or write to the device. In this particular case, I'm going to read from the device. Okay, so array, just a big number in there, doesn't matter. Let's configure the timeout. Integer, the timeout will be just 1 second, which is in milliseconds. Okay, as you can see here, timeout. And another one should be for indication of the execution of the function block. So indication underscore status. Okay, this one missed. There we go. So now the easy part, just drag and drop all the values here, input, base, okay, object here, and I put it here just to show you something else. There we go, timeout. And finally, the status of the execution of the function block output. Good. This one in particular, okay, we need to use the function which is located in operator and standard blocks. Let's use the folders. Standard RDR, okay, the address of this to get access to this information. Okay, so this information, the array will be stored the information that we read from the slave. Okay, as you can see here, if we just add a new line here, button, the variables should be something similar, okay, with a different array to receive information. For example, write. I believe this one FC6, if I don't remember wrong. Just double check. Right, single holding register. Okay, I was right. So if we just drag and drop, you can see here we have the address, the base, okay, the base, and the object where we're going to store the information. In this particular case, it's just a single register, okay. But if we want to read more information, for example, FC16, we're going to have the number. So there we go. I will need to treat the object the same way. Object properties. See the object, we have the at the beginning. Okay, the right pointer. So now, okay, we have already defined this. Now it's time to compile and unload everything and check the values. So let's compile and validate that we have everything good. Good. No errors, no warning. So now what we're going to do is to download the application to the controller. Before downloading the application to the controller, let's see how we can share that information with the embedded display. So far we know that the information would be stored in this variable, which is internal. So let's create two variables, okay, to have this information. Okay, we're gonna save the changes and go here to the status. I'm gonna use our indication the M1, and specify for humidity is integer. I'm going to use another one for the temperature. Okay, this I for integer and I again for integer. So I'm going to try to send this information from the device in these variables. So I'm going to compile. We do go to programming, and let me just double check which one is first. Temperature first. So if we go here, we want to use the temperature. This is basically how you can use in your program, but in this particular case, we're going to use the temperature and humidity for the sensor. So this would be like this. It should be the first element in the array. Okay, copy and paste it. Oops, sorry, this one. Copy and paste it. Okay, and it should be the second element for the humidity. So if we go here, status, temperature will be the first one, should be output, and then humidity, the second one, output. Good. So let me just minimize this. If we go to standard blocks, we have the move function. I'm gonna put it 2 times there and there. If we probably want to compile this, we're gonna have an error here. Okay, more than 2 words per block. Okay, so one way should be to create the enable in both, okay, and link that as we saw in the diagnostic and use the throw here. So we can continuously moving this information of the device into the variable that we want to share. So let's compile again. There we go, no errors. So let's say this and check how we can use these variables in the display. So far we have this temperature, we have the menu, we have the welcome page. So we can create a new page here on a copy and paste. I'm gonna change the name, temp TN1. Okay, we have this. I'm gonna close all the windows just in case I'm modifying this one only. Temp humidity message. So let's delete this. I'm gonna leave it. So temperature and humidity. Okay. Oops, I don't like it that way. Humidity. Temp. So let's try to do this faster. Local parameters, we should be able to see here the new variables. So we have the humidity here and the temperature. Just drag and drop. Okay, 5 and 5, just in case. So now we need to call that. Let's go to the menu, Control C, Control V, copy paste. This would be sensor TN1. Just to show you how is the navigation in the display when I record that part. So temp TN1. Okay, I'm coding the same. Open page in this one. And in this one, I can go back. So here, access it should be only read-only. We cannot change that. Okay, so now we can compile this and verify that we don't have any error. Okay, good. Okay, good. So now what we're gonna do is to download the complete application again. We'll see the welcome page, start, go into the menu. We're gonna see here and get access to the information from the device. Okay, so let's just save this and then make a download of the project. So let's check now. Okay, this is the connection that I have with the controller. Okay, this is the all application that I have. You can see the cables connected and I'm using the power supply in this case of the PLC, okay, to energize the sensor. Okay, just put it in this way. Now let's check how is the communication. Online certain communication Modbus TCP. That's the IP address. Okay, let's verify if we have connection. Ping. Is not replying. So let me just double check. Could be the problem here. Good. Now it's connected. So we have connection. We can connect. Okay, and let's just download all. Okay, good. We just need to wait. See the PLC side. It's gonna take time. Okay, I want to download, yes. Yes, I want to reboot it. There we go. So now it's gonna reboot. As you can see, the application was downloaded for the HMI side. PLC loading, communication, everything in there. So let's try to go here. Okay, too much live for you. Okay, so let me just wait. Okay, there we go. So you can see the temperature on the sensor. Let's go. Just go repeat there. Okay, so let's go to the next, which should be the temperature sensor. Okay, let's wait till it. So, okay. If we connect to the controller once again, we are connected, it's the same. Good, everything is configured here. So if we read this, go one, set, we should be reading something, okay? Which is the status is 0, no error occur. Okay, let me just check something here. If we go back here, no, this one. Okay, so as you can see here, we have executed the Modbus function number 3, okay, with this to the address 243. We're reading the register number 7 and 2 registers total, one for the temperature and the other one for the humidity. And that information that we're reading is stored in this array. That's why we are using in this way the array to move those values to a status variable, okay, and that status variable are linked to the embedded display, as you can see in here. Okay, so if we execute this again, we should probably see another values or the same ones. Okay, so let me just put zoom out, manual zoom out. Okay, so if we change this, okay, you can see that it's constantly reading. Okay, I'm touching the part of the proof. Now, if I release that, you can see here that the humidity is decreasing. Okay, the temperature, of course, is a little bit slower. So, in this way, so we have done is to how we can use the Modbus object, okay, the functions to get access to any slave, okay, over Modbus. Okay, so let me just double check something if I'm missing something here. Okay, good. So what we have done basically is to read the information. Okay, this is an example. If you want to read the complete information from the device, okay, the complete from the 1 to the 14, okay. This is an idea how is the visualization of the complete data. Okay, you can see here the address and everything is in there. Okay, so what we're gonna do now is to explain another way to use the Modbus master of the PLC, okay, using the I/O scanner as we saw in another PLCs. So let me just put this in another way. Okay, and let's go back to our application here. Let's disconnect. So now what we're gonna do is to remove this from our execution. Now we need to go to the configuration and check the port for the Modbus, the one that is master. Okay, so far we have used the function blocks to get access to any Modbus slave using the function block with the function code for Modbus. And now we're gonna use a different way to get access to this information. We can generate a generic Modbus slave so we can easily share information, okay, read or write information to the slave. So we avoid using this function block, okay, creating these variables to share with the function block and execute it. There is an easy way where we can just define the slave, okay, and automatically read or write that information, okay. So this is the advantage in this particular part. We just define the slave and we can easily share this information, okay, read or write some registers in a fast way. But the thing is that if we use this, okay, we predefine the Modbus address. So we are not able to change that when we have downloaded the application to the controller. So this can be the disadvantage if you don't want to use this. As you can see here, I link the address to a variable, but I can just easily do this, okay? Create a constant and link it to the address. Okay, I don't change that, but in this particular case, I have used a variable, so I can easily change the address of the equipment and get the information. But let's go to this way, as we call the scanner way, the Modbus Serial scanner. So we need to add a new slave here. I'm gonna, no, sorry. I want to change the name here. So I'm going to use the slave TN1. Good. I predefined the Modbus address as 243. Now there is nothing else to do regarding the configuration of the slave in this part. Okay, we just need to match the slave address that we have already configured, and this node name will help us to diagnostic communication. So once we have defined this, we need to add some objects. They are related to the function blocks that we already use in the programming part. Okay, so in this example, we're going to read some registers. So I'm going to use the Modbus function number 3, select. As you can see here, okay, we can remove or copy. So the start address for this will be the number 7 again. Okay, as you can see here in the programming, we need to match this information now. We already have done that. Okay, the address. Now we need to configure the initial and the amount of variables that we want to read. So if we go back to configuration, the start address will be 7. I'm going to use continuous read. That amount is here. So holding register, you can see here the address. I'm going to add another one, address 7 and number 8. So this is regarding the variables that I want to read from the slave. Now, how can we link these variables to using in our program? It's very simple. We just need to press assign, and we can see all the variables that we have defined in the status. So I'm going to reuse these ones that I have already created for the programming. Okay, as you can see here. Now there is no conflict between the program that we have done before, because this part of the PO is not called in the background, so it shouldn't be any problem with that. So we have defined the variables for the registers. Let me just double check if the 7 is the temperature. The first one is the temperature, okay, and the other one is humidity. So what we need to do now is to download the application to the controller. So let me just double check. Okay, it's different. And now what we're gonna do is to download. Let me just bring this here so we can check that the information that we're reading is correct. So download, cancel, first compile. Okay, let's compile everything. Put in here. Now let's proceed. Yes, I'm sure. Now wait. Okay, there we go. So in the display, we shouldn't see any difference. The only thing that we have changed is how we can get access to the information in the PLC. That's the only change. Instead of using directly the function blocks, now we are going to use the scanner of the Modbus master to easily read the information. So let's go back to the display here. Sorry for this, but I go. You were not able to see it, I think, very well. So if we go OK, we should see. Let's wait until it stop. OK, the backlight. Good. It doesn't look so good. Zoom out. Okay, as you can see there, let me just make the image a little bit bigger. So you can see here that we are reading now in a different way the temperature and humidity. As you can see here, I'm gonna touch the proof. You shouldn't do that. You can see here that is raising. Okay, so this is the other way to analyze the communication between a master and slave over Modbus serial using the I/O scanner of the PLC. Okay, so for me, I think this is a fast way to implement the Modbus communication. As you can see, the only thing that you need to do in the PLC is define the slave, the address, and the variables that you're going to use, okay, and the start address. Instead of using, for example, the function blocks that you are able to see in the target blocks, okay, if you use this, you will require to create these variables and it takes you more time. But the advantage of using the function blocks is that you can configure as you wish using a variable, the address and the amount of variables that you want to read or write, okay, and you can decide when you can read the information from the device, okay. So that should be the difference now. Okay, so what we're gonna cover now is there are some predefined slave that we can use in order to make the things a little bit more easier. Okay, so now let me just put this in the other screen and disconnect. And now we're going to show you how you can get access to the temperature and humidity sensor in an easy, fast way without remember the addresses, what register belong to the temperature and the other one for the humidity. Before doing the implementation of the predefined slaves, what we're going to do is to see how we can diagnose the communication. So if we go to programming again, let's connect. If we go to operator and blocks, and we select target variables, let me just go back. You can see here Modbus master. If you're not able to see that, click view folders. So Modbus master, double click, and you can see here that we have an structure for sys Modbus RTU node status. This is a structure with all the possible slates that we can have, the address. So in this particular case, okay, you can see here that we are trying to communicate with a slave, okay, 243. There is presence, okay. Let me just bring this here, okay. So let's zoom out. Shoop. Okay, good. So as you can see here, using the communication, okay, this block. And if I remove this, we should see something here and a new state. So let me just remove the Modbus cable. There we go. As you can see there, we see the miss isn't true, and we have a different state in the Modbus. So if we go back, there we go. The present is again. Okay, so let's go back again. Disconnect. You're going to change the value. Okay, you're going to press here. As you can see, there is no change in the values. So if I connect again, see how automatically it changed the values again. So we have connection. So if we don't want to use the watch to know what is going on, we can easily, let me just disconnect from here, put this in the other monitor. We can use in the program diag this variable. So let's remove this variable input. We can type this is sysmp rtu node status between brackets 0 dot miss. Okay, good. This 0 belongs to the configuration that we have done here, not this one, in the slave, the node number. Okay, so now if we connect to the controller, okay, different, we need to download this, compile download. Good. Now, if we remove the connection, we should see that in red. There we go. So there is no connection. And if I plug in again, we have again the connection with the sensor. Okay, this is just an easy way to know if we are talking with the slave or not. And now let's go to the configuration, okay, of how we can use the predefined slaves. Now we're gonna see how we can add a new predefined Modbus slave, but let me just double check in the presentation if I don't miss something. Okay. Okay, this is the part that we can play with it. Okay, if you want to use these values in a real, you just need to use the int to real function. Okay, we can see in the other, we saw in the implementation, the first models, this is the variable. We have already explained this. Slave failure. Okay. If you want to know the exact problem that you have in the network, you should probably read this one, this state, and you can see here what's going on. Okay, this is good. We already seen this. Drag and drop, miss. We already explained all this part. So now let's create, okay, our predefined. Imagine that you are using too many, in this particular case is a temperature sensor, temperature and humidity sensor, but imagine that you are using for example, a PLC, M221 or a different PLC, and you want to use the Modbus, and you have plenty of them, and instead of creating just one by one, okay, add and all the registers, it's much better to use this Run Modbus Custom Editor, where you can just predefine, in this case, generic TN1. Okay, you can make the description. I'm going to use RTU. I'm going to predefine, for example, TM1 temperature TN1 humidity. Okay, we can specify read-only. We can specify the address. So we predefine our Modbus slave. So instead of using these functions a lot of time and wastes time, we just need to create our predefined Modbus slave. So I'm gonna save this, save, and it's gonna be automatically saved in this folder. Okay, I'm gonna use training TN1 temperature and humidity device template, save. I'm gonna save this, I'm gonna close. Now I'm gonna leave this, but I'm gonna change the address. I'm gonna change the node name, the node number. So now I'm gonna add another display, okay, another generic Modbus slave. You can see here the generic TN1 that I have created. Select generic. We just need to predefine the Modbus address. The node number will be 0, so we can identify when we don't load the application. Then we have the inputs and outputs. You can see here that the address is predefined and humidity. Now what I can do is to assign a variable. The first one is temperature and the other one is the humidity. So one thing that we need to do is not enough to change the knob number, because I will be overwriting this information. So I'm just gonna simply remove this and work with the predefined generic TN1 that we have created. So this should be an easy way to replicate slaves that are not generic, okay, and we want to make it generic for our purpose in the application. So you can see here that we have linked the same values to this slave. So if we just compile okay, good. Now we are gonna put this in here. I'm going to connect. I'm going to download or restart. Good. If we just remove this, we'll see that we don't have communication. I'm gonna touch the proof. Okay, you see there is no changes in there. And now I'm going to plug in again. And you can see that we still have communication now, even if we change this device. Okay, so this is a better way to work when we have different slave and they are not generic and we want to use multiple times. So let me just disconnect from here. I'll put this in the other way. There we go. And now the last thing that I want to show you is that we already have some default slaves to be used. Okay, we have created this one, and in the past I have created this one, but if you can see here, we have the Altivar family. Okay, we have, for example, the spatial bulbs. Okay, that comes by default, and then we have here the same device that we have already created before. So if we add this one, okay, as you can see, there is another icon. Click, we can still define no number 0. I'm going to delete this one, remove input and output. And if we add something, you can see here that we have the complete information because someone has already programmed this. Okay, so for example here, analog input 1, that it should be the temperature, and the analog input 2, it should be the humidity. You can see here that you have the address. I haven't paid attention on that. Here you see the address. Every start with 1. Now if we just assign this, okay, temperature and humidity, connect, we're gonna compile, connect, and gonna make a download. Okay, it should also work. Okay, let me just disconnect this to verify. Okay, we lost communication. It's not reading nothing, even if I touch the proof. Yes, it's still reading. Huh, because I haven't disconnected. Okay, now I didn't disconnect the Modbus. The other one was for the CAN. Now I disconnect the Modbus. As you can see there is no increase or decrease of the values. And now we're gonna plug it again. We had connection and it has changed the values. Okay, so the idea of this part is just to show you there is something already created for the humidity and temperature sensor that you can easily use. There is no need to make your own device, or there is no need to use the function blocks that we see here in the communication for the humidity and temperature sensor. But if you have another device that you want to communicate over Modbus Serial, you can use the function blocks, or you can use GSCAN. Okay, some interesting thing that you need to know is that in this one, if you want to use this, you are not able to change on runtime these values. Okay, for the Modbus address, you should probably take this to easily change the address here in the configuration in HMI or in the embedded display to assign this in a new variable, and then you can change that on runtime. Okay, let me just double check if there's something else that I'm missing. Okay, no, I think that concludes everything regarding the Modbus master for this part. Okay, so if you have any question, just give us a call or send us an email. See ya.